for this computer because everyone can hear me. Okay, so I'll pause it over here. Let me clear all the drawings and 1 minute. We'll go to a small video clip on YouTube about distillation with condensation. So let me check. Okay, here's a small video for you guys. Let me share the screen and here we go. I think this is inappropriate. This is for the kids. But from where does he start about the distillation? Yeah, at this point, I think this is where the distillation starts from. This is the equipment for the distillation, and it shows you the thermometer and you're heating it up. So you gotta remove the voices. There's too much music in it.
Let us perform an activity to understand simple distillation. Take a mixture of acetone and water in a distillation flask.
Okay, before we go on further, there's a reason to put a thermometer, and the reason is the liquid that we are mixing together, acetone and water. The acetone has a lesser boiling point as compared to water. So once we are heating it up, we make sure that it stays around 60 to 70 degrees because this is where the acetone boils, and the water is going to boil at 100. So this is also known as fractional distillation. So we are keeping the temperature at 1 point until acetone completely boils up. We will liquefy the acetone, and then we are actually removing the water from the acetone, right? So this is why we keep the thermometer, and we're gonna boil it up to 60 to 70 first until it stops boiling. That means the acetone has been completely evaporated and it's completely separated from the water. So let's check.
Put a thermometer in it. Connect the flask to a water condenser. The condenser has cold water running through its jacket to keep the temperature cool. Keep a beaker at the outlet of the condenser. Heat the mixture, keeping an eye on the thermometer. When the temperature hits 56 degrees Celsius, acetone starts to vaporize. These vapors condense in the water condenser. The condensed acetone gets collected in the beaker. When all the acetone vaporizes, water is left in the flask. Acetone is collected in the beaker. In this way, acetone and water get separated by simple distillation.
Ah. Huh?
Yes, we have a question. Sound?
Teacher, I know that the school, makes you learn and stuff like that, but there's a lot more suitable videos for our age about distillation and the process
I agree.
on YouTube.
Yes, I know. But this was spontaneous, as what we call Hassan was asking for it. And I said this is not appropriate for our age, but it was just a small demonstration of what is happening. You're looking at the temperature, and then you are keeping it at around 56 to 60 degrees Celsius so that acetone evaporates completely. And inshallah, I'll try to put up the more appropriate video for you on your level.
Okay, thank you, teacher.
Yeah, you're welcome. I totally agree because the kid was laughing like a joker and the music behind it, the sound effects were absolutely inappropriate. Agreed. So let's go to the other part. And Muhammad, yes, Masudi, it would be keeping some of the water vapors will be added to it. It won't be pure acetone, but you have done the, what do you call it? 95% you have done the job. So let's begin with the presentation and separation techniques. Who would like to explain things to me about the first slide? Why we need to separate? Why we need separation techniques? Yes. So Abdul Wahab, where is Abdul Wahab? Yes, Abdul Wahab. Oh, Abdul Wahab was in the waiting room. Sorry. So Saidi, would you like to read this? Abu Saidi, we cannot hear you. Your mic is on mute.
Hello?
Yes, now we can hear you.
Why we need separation techniques? Deal with the separation of mixtures to enhance purity of substance are important because most substances are needed in their pure state.
Criteria?
Criteria of purity.
Yes.
A pure solid has a sharp and constant melting point. A pure liquid.
Yes, there's a question.
Question: how do impurities affect the melting and boiling points?
Impurities. How do the impurities can affect the melting and the boiling point? If I add something into a liquid or a solid, will it affect the melting or the boiling point of it? Is it going to increase the melting point or is it going to decrease the melting point? What is going to be the effect of it? So let's check the answer. Where is the mouse? We will discuss this in the coming slides. So would you like to read the second slide?
Substances in a mixture are physically combined, so process based on difference in physically properties are used to separate components. Particle size, solubility, insoluble and soluble, degree of solubility, density, magnetic, iron, vis, non-magnetic, Sublimation from solid to gas.
All right. He says the substances in a mixture, they are physically combined. So the mixtures that are going to be created, the impurities that we are looking at, they are not chemically combined, they have to be physical. If they're chemically combined, then it's going to be a new compound, it's going to be a new substance. It's not going to be something which is impure. The impurity is always created by a physical combination. And the physical combination would be disturbing these four things, five things actually, like the size of the particles may differ, the solubility will also be affected, and the density will be changed. And if they are magnetic or non-magnetic, these property will also be changed, and they might become sublimation. If they were sublimative, they will not be changed to something else, and these properties will be disturbed if they have impurities. All right. So let's try this slide. And do we have Huzaifa in the room? No, Huzaifa. Can we give the mic to Omar? Omar, would you like to read? Let's check.
Yes, sir.
Thank you.
Techniques of separating mixtures. Numerous techniques have been developed to separate mixtures to static components. Magnetism, decantation, evaporation, sublimation, filtration, centrifugation, extraction, distillation, crystallization, adsorption, chromatography, chromatography.
So these are all the techniques for separating the mixtures. And I think we will be studying a few of them. Let's see. The first one is magnetism.
Should I read?
Yes, please.
Magnetism. A magnet can be used to separate a magnetic substance from a non-magnetic substance. A magnetically susceptible susceptible material is extracted from a mixture using magnetic force.
So that is the easy one. If something is attracted by the magnet, we can simply use a magnet to separate the mixture. Like sugar and the iron fillings, they have been mixed together, and you can separate them by introducing a magnet to it. And the second diagram shows that the beads are bound to
Mister,
molecules. Yes.
like even magnet can pull sands because sand has iron in it,
Sand
right?
contains iron particles? I don't think so. Should we check this? Let me check this for you guys. Sand contains iron particles. Do sand. It's gonna be very little. And if there's gonna be iron in it, it's gonna be like in the compound form because iron doesn't come in a free form. Yes, the many sands in southern Europe have iron impurities. Crystals of the sand give a deep yellow color, so they might contain garnets and other resistant minerals. So they're gonna be available in the form of a compound. It's not gonna be available in the form of what do you call pure iron or even iron as we know, which is being attracted by the magnet. It's going to be available in the form of a compound, in a salt or in a mineral form. Sorry?
Okay.
Like what?
No, that's Hamza being maybe. That's just Hamza being absolute.
So the language, boys, please. Okay, let's go to the next slide.
Decantation. It is simply to pour.
Decantation.
Oh, decantation. It is simply to pour off of upper liquid layer, used to separate a liquid from an insoluble solid. The solid stays in the bottom.
Yes, we also call it skimming off. That you leave the mixture, what do you call it? You leave the mixture on a standby for a very long period of time, maybe 24 hours, maybe 30 hours. And what's going to happen? All the solid particles will start settling down, and the liquid comes on top. So you just skim off the top layer. What was that? So we are just skimming it off. Let's give the mic to Hamza. I think Hamza wants to read the next. Yes,
Yeah,
Hamza.
Mr.
Evaporation.
Okay. Evaporation. Hamza, your mic is off. Oh. Then mute your mic.
Hello.
Yes, Hamza. We can all listen.
Hello, mister. Can you hear me?
Yes, yes.
Okay.
Loud and clear.
Evaporation. Evaporation to dryness is used to separate a dissolved solid from a liquid. The dissolved solid must be heat stable. In this method, the mixer is heated. When the mixer has completely evaporated, no water is left behind. The solid salt left behind at the residue.
All right. So the first thing is evaporation to dryness. You're gonna evaporate things until the water completely evaporates and the dissolved material is left behind. So the dissolved solid must be heat stable. Yes, it shouldn't be like sugar. We don't use the option of heating a sugar solution because the sugar gets burned. It releases the hydrogen and oxygen, and the carbon is left behind. So you have the black material as carbon. So in this method, you're gonna heat the mixture, and until the water is completely evaporated, and the solid which is left behind is gonna be the residue. So the term residue means the left behind material, the dry material. So in this, you can see there's a green solution, and once it's gonna evaporate, you're gonna have a green substance in the form of a powder or maybe in the form of crystal, depending upon which salt you have used. Right? Right or left?
What?
Did you understand what I just explained?
Yeah, yeah. Yes.
Okay, good. What is happening in this picture?
I think like seawater. It says here evaporation of seawater just produce salt.
We are going to produce salt. How will this happen?
By heating the salt water,
How can we heat the salt
right?
water?
Uh, this part I don't know.
You're using the sunlight.
Oh,
The sun's heat is good enough to evaporate all the water, and the salt is gonna just stay behind on the ground, and then they would
and what's the temperature?
any temperature, like
To
30 degrees, 45 degrees, 40 degrees is good
hmm,
enough for the water to evaporate. We're not gonna boil the water, we're gonna evaporate it.
okay, okay.
Okay, so let's go to the next slide. Oops, what is this? Separating a solid that sublimes on heating.
Sublimation.
Yeah, sublimation.
Separate a solid that sublimes on heating. Sublimation is the process whereby the substance changes from the solid that sublimes upon heating from another substance with a high melting point. The mixture is placed in evaporation dish. An inverted funnel is placed over the mixture on gentle heating. The salt sublimes and disposed on cold filter funnel. This method has limited use because very few solids will sublime on heating. For example, ammonium salts, and dry ice, and carbon.
Okay, it's ammonium salts, iodine, and dry ice. So sublimation is actually a process where we know that the solid is going to become a gas without becoming a liquid. The mixture is placed on an evaporating dish, and then we invert a funnel over the mixture, and we gently heat it. The salt sublimes, and it deposits on the cold filter paper. So the salt, when it is subliming, it becomes a gas. It takes away the particles with it, the pure particles. Once it goes to the funnel, it goes into the reverse of the sublimation. What was the reverse of sublimation? I kind of forgot the term. So this method has limited uses because very few solids are subliming. And they are examples: ammonium salts and iodine and dry ice. Other than that, I haven't seen any other example of which they can sublime. So this is how it looks like, the process. The sublimation used on one of the solid sublimes, we have a mixture of iodine and copper. So the copper is going to stay behind as it is, and iodine is going to just turn into a gas and go up into the air. And once you collect these gas particles and let them, cool down, they will become an iodine again. Mixture of ammonium chloride and sodium chloride. Ammonium chloride is also a sublimative salt, and we usually keep them in a form of a solution in the lab. We don't keep them as a solid because the normal room temperature, 35 to 40 degrees, can actually help the ammonium chloride to sublime as well. So this is how the apparatus is gonna be. You just invert a funnel, and on top of it, keep the, what do you call it? Somehow I just keep on forgetting. What was it? The funnel of the mixture on top of it, and then we have the funnel, cold filter funnel, with even on the top, what do you call that thing? A collecting test tube can be used to collect the gases and just keep them, cool them down in an ice bath, and you can convert them back into the solid state. Anything can sublime at enough pressure, at low enough pressure. Anything can sublime. Masudi, can you please provide us with the example, and we will inshallah look into it. Okay, filtration. Let's give the mic to Abdul Wahab if he's with us. Abdul Wahab, are you there? He's not there, so we'll give this mic to. Okay, Masudi is showing the phase diagram of water. Is this what kind of a file is this? So let's open it, file. Okay, so he is showing us, this is the boiling point, and this is the vapors, and this is which part is the critical point, solid, liquid, vapor, triple. So come up with the example, please, and we will see this graph as well, inshallah, in detail. So Hamza, please read the filtration as well, and then I'll give Basuri the next slide to read.
Okay. Filtration. Can't see some. Oh, okay. Used to separate the heterogeneous mixture composed of solids and liquid. Use a porous barrier to separate the solid from the liquid. Liquid passes through leaving the solid in the filter paper. Gravity filtration to remove solid from imputation from a liquid or a solution. Vacuum filtration to remove solid substance, usually inorganic, from.
All right, can you hear me, boys? Because the internet shows that it's unstable. Hello, Hamza, can you hear me? Or the boys, if you can hear me.
Yes, teacher.
Basiri, can you hear me?
Yes, I can hear you.
Okay, but what happened to Hamza?
I have no idea.
I think his internet went down.
Maybe his mic ran out of battery or something.
Okay, so let's go to that picture that you have shared with us. Can you please explain this? Do you want the mouse, annotations,
No,
control?
what I'm saying is, on the left we have the pressure, and on
Yes,
the top we have the temperature. This is a type of graph
right.
showing what happens to water at certain temperatures and pressures.
Good.
You can see at low pressures at 100 PA or 10 PA. If you go about 300 K, you can make it go straight from solid to vapor.
Where is that? Yeah, I want you to grab the mouse and
Like a
annotate that
solid
part.
liquid.
Yeah, I'm gonna give you the mouse. So hold on. Okay. Can you grab the annotation tool? And 1 minute, let
Yes,
me
I
add
use
Mohammed
that.
Gary.
So what
Okay,
I'm trying to say is, if we have, if the pressure is at this point
yes,
and
this
the
is 100
temperature
Pascal.
gets hot enough,
What is the
we can go
temperature?
straight from solid to vapor.
Oh,
Temperature
okay.
around here, 300 K, maybe
Minus,
250 Kelvin.
it's okay. Hold on. Look at this. The temperature is on the top. You're looking at this bottom. The grace point over here is going to be this one. Let me grab the mouse. And we are over here. We're looking at this point. This is the 100 Pascal, which is very low pressure.
Yes.
Plus, it is around at that point, the solid liquid vapor triple point, that would be a 0 degree Celsius. But if we are looking at these points, they're extremely cold. And the sublimation, this is at freezing at 1 point, boiling point will become at that. Yes, the boiling will be reduced as we reduce the pressure, but it also would have to decrease the temperature as well. 300K and 250. Yeah, 300K means the same thing. 100, 300K is 273. This should be zero. This should be zero. 273 is zero. Okay.
So what I'm trying to say is that water can also sublime at low enough pressures.
Water will be subliming if it is into ice at a very low temperature. Yes, water vapors will come out straight away without melting because you have decreased the temperature as well.
And I'm sure
So
other this can also do the same at
this
low
is
enough
the
temperature.
this is an artificially created controlled environment. Yes, you can experiment with that, but naturally sublimation at room temperature is only 2 to 3. What do we call it? Why the screen sharing has stopped? Okay, let me turn it on again. So it has to be under the normal circumstances that you have a solid at a room temperature and you started to boil it or change it into liquid, and it straight away goes into a gaseous form. And yes, playing with the temperature and the pressure will be changing the scenario as well. You might change the properties, how they would react. So let's see. We are finishing off at this slide, which is slide number. Sorry, which is slide number. Again, the screen is sharing. 12. So we'll begin with our lesson next class at this point. 12. I'll put a star on that. And that would be all for today. Where did my recording go? Yeah, there it is.